3, 2, 1.
Cool. Welcome back to the Powermetrix time machine. We are filming into the future. This one will be shown on the 19th, which will be right after Easter. The 26th, the week after you'll be seeing this, we'll be doing a round table with Martin Hyatt and Kent Lowry. Those are the guys that cover the central third of the U.S. and the western third of the U.S. for us, and they'll be coming in and we'll have a round table. JP is going to put out there on the website, if you have any questions about any sort of metering, meter testing, please send them in so that we can answer them. We'll just be talking about meter and CT testing, and we'll be talking about connecting issues. We'll just have a round table about stuff that we've run into, and so that's going to be cool. We will finish up the one I'm doing today will be the second part of that 3S meter with Padmount. We already did the 3S meter overhead, which was the school one. You know, in this case, it's always 2 currents and the 1 voltage. So we 2 voltage, 1 current, excuse me. And so we're going to have A and B voltages, and then we have the 1 current that's measured. And I'm going to point that out here on the machine. We have just 1 CT, and I'll talk about it some more in a little while. So we're going to do that, and then May, June we take the summer break, and we will do we'll go do some more filming. JP and I will a couple of weeks, and then that'll give us a lot of fodder for several months into the future of this year. So so we're going to be doing that. As you know, we always talk about if you would like to get some training, individual training, please do so. When you see this, we'll be getting closer to Mid-South Meter School. It's the first week in May. I'm looking forward to that. Got a lot of friends and part of the Powermetrix family. They're there. That was my first meter school I ever went to. So it holds a special place in my heart. So I was awful confused that first day walking around the meter school. I had barely started with the company then. And so be walking around. I was walking around there and trying to figure out what this stuff was all about. And so we will have the star behind me will be there, the bench. We will have a room with the bench in it. So if you want to have any of your techs show up there and let them know if they're coming already, or if you would like to, sign them up and send them, they can get individual training. That's what we have it there for. So we'll be able to, they can bring whatever equipment it is. It doesn't have to be our equipment. That's not what this is about. It's universal to anybody's equipment. So you could get a training on that, and we can run some error scenarios by them and go through testing, because we know some folks have a lot of other hats to wear. They don't just get to test all the time. So a good refresher they could get while they're up there and go over different meter forms with different errors and different problems on those meter forms. We'll be able to do a 3, a 4, a 5, a 6, and a 9. So and an 8. Just don't see those much, and we'll be able to go over all those meter forms with different error scenarios on all of them. So if they want to do that, it's all about the connections really is what a lot of it deals with, but also all that pre-test checking and all that. So we'll be able to go over all that with your guys and also your girls. I don't say that enough. Men and women, both, all your techs. So we'll do that and go over that with you if you like. We love to do the training. So so I asked them to just get a hold of us, and we'll do it. We'll have it in a room there for everybody. We're also going to use it for some classes. So look forward to seeing you all there. And then also, if you do want to call in and get a demo of a bench, we could do that too. But it's really more about the training, right? So that, and then what are we going to be doing on this one, JP?
There you go.
I should have that memorized by now. Here's the agenda. So we're going to do a quick recap on where we are, connection tips, testing the meter, testing the CTs, and then looking at the results. So we'll be doing that. When you see this will have been just after Easter. Big day for us as Christians, so I'm going to go ahead and open with a prayer, and then we'll get into it, and I'll stop it like I usually do and make some comments and also point some things out on it. So let's go ahead and get started with a prayer. Precious Heavenly Father, all of the the most precious privileges that we have in our lives. Freedom, salvation, all those come at a heavy, heavy price. And when folks see this, we will have just celebrated as a country Easter, the death and resurrection of your Son, Jesus Christ, the incredible process that allowed me to even pray right now, that promises us when we give our hearts to you eternity in heaven. And Lord, it is just incredible to think that you did that for us, a sorry wretch like me, a hard-headed sinner. But Lord, thank you so much for that. And we give you all the praise and glory for your mercy and your grace to do that for us when we are so undeserving of it. And Father, I just, on a just John note, just thank you so much for everything that you give me in my life. I know that I'm going to look back one day and just feel so unappreciative of what you've done for me. I know just in this job so far in 8 years, I have come close to losing my life 3 different times. And the fact that you still have me around makes me think that you've got more in store for me and for all of us out there that are still living under your grace and mercy. So I sure hope that I can live a life that I won't have so many times that I look back on and seem unappreciative about. And Father, I just thank you for each and every day you give me. And in those days, just Father, let me, I guess it goes back to what you say in your word and what your Son said, that in the midst of talking about the chaos that would come before he left, as he did the disciples he had then, and how tough times were going to be for them, and all but one of them was martyred for him, but also the times that were coming before his second coming. And we're seeing tough times now, but in the midst of all that, in Luke 21:13, he says, and these will give you the opportunity for your testimony. And Father, that's what it is. We are walking, talking testimonies for you. And so in my actions and in my words, please let me show what the light is that shines in me. It's not me. It's not John. And so, Father, thank you so much for what your Son did. So I even have that ability to be able to talk about my salvation, to pray right now. So I'm going to use the privilege that you give me to lift this country up right now, for lift up the folks in Ukraine and just this, what seems to be a crazy mixed up world right now. And Father, it just seems like we are turning away from you more and more and more. But hopefully in the midst of all that, I know it sounds crazy, but when times get tough, that's when people are bottomed out, there's nowhere to look up, right? So hopefully people will turn to you. And if in the midst of all this, people are praying more and turning to you more, and what an incredible thought that they will also become saved and experience salvation through these tough times, then bring it on. And Father, we know that we're due for suffering. As my buddy and I always say, it's got to get worse before Jesus comes. So, it says to welcome suffering, and the reason that we welcome that suffering is know that we need to go through suffering as well, just as your Son did, and just as we celebrated the terrible suffering he went through on that cross. So thank you for that. Thank you for what your Son did. Please give folks traveling to and from the Mid-South Meter School safe travels, and help things be brought to people's attention at the school that may help them stay out of trouble, that may keep them out of harm's way. So all of these things I ask and say, according to the will of the one who paid it all, my precious brother, Jesus Christ. Amen. Cool. All righty then. So we, at this point, we did an inspection. We had our first little, we started to try and do something, but it started raining on us, and we tried to show some good field safety practices, and we said, no, we're shutting it down. Ticked off JP because we were promising 10 to 30 minutes, and we only got 3. And JP set all of his cameras up. Y'all just have to see. I will point this out. If you notice sometimes in the background, you can see a shadow. And yeah, it looks like one of the Transformers with the thing sticking out of the head and all the other stuff. No, that's not. That's not what that is. That's JP with cameras and antennas and everything on it. So he got everything set up, and then the rain started coming. So we had to shut her down, and we went to the second site that we're on now. So we're on the site now, the second one, beautiful sunny day. And I think it's nicer on that day because you can notice I even slowed down a little bit the way I was talking, which I thought was funny. Because the first one I was trying to hurry up, maybe, I don't know. Or maybe I just had coffee. I don't know what it is. But anyway, so in this second one, we're going through this 3S Padmount. We have looked it over. We had some insect issues. You could see a lot of ants, but what was funny, we thought it was maybe a snack bag in the bottom of it. You'll hear in a minute it was actually ant poison, so that's why there were no ants there. Just you can see where they had been there. You can see where they even sprinkled the poison around in there. If you look closer, you can see it, the powder and stuff that was in that bag. So that's why you can see remnants of an ant colony, but no ants. So so they put the poison in there and got them. But so it was. You can see that it's tough with those conductors from A and B phases from the currents going through that same transformer. So the way we look at it is we actually measure just one current with that one CT current transformer, and we have 2 voltages. So and I'll point something out here in a minute about that. But so we go in there and we've cracked into it now, and now Jonathan is going to. You got to get kind of creative with your connections and things on there. And we have such a small can there that we're actually going to use some clamp-ons right there and also there's no test switch, so nowhere for the duckbills to go. When that happens, you go with secondary clamp-ons to pick up your currents because you're just going around the wires. So you'll clamp on around those wires to pick up your secondary current, and our primary current we're still picking up with the red flexes. So so we're doing it that way this time since we don't have a test switch to put the duckbills in. So we're making our connections there and using the alligator clips to pick up A and B voltages. So we're going to test this 3S Padmount, and as you'll see in here, I'm going to point some stuff out and stop. But there are different ways to accomplish picking up that primary current, and I'll talk about that here in a second. But we'll go ahead and roll it, and I'll ask JP to stop, and I'll make a few comments and point some things out. So.
Okay, so now we've hooked up here, and we took a moment because if you could have seen our boy hook all these things up, Jonathan had to do a little bit of a finagling to get this thing. So first of all, you can see just how tight the can is right here. So he got the clamp on here. So you got to remember everything's directional when you're measuring current. So there's an arrow on that clamp.
And I guess things are also directional with marriage. I don't know why thank you very much. I don't know why I said that, but in retrospect, I think that's kind of funny. So you need to make sure you're going in the same direction as your spouse. It's kind of like those currents. When they're going opposite directions, they can cancel one another out and not be effective. So maybe that's what I was thinking. I don't know.
On right there. So he had to get his arrow in the correct direction here. There's our pickup. That's not a big deal. But now let's come over here and see. That's his picking up his current. What about his voltages? This was his best access point. Come in here. Okay, now you'll note.
Hey, John.
Yep.
Remember that green wire?
Yep.
Have a look at it.
That might be, huh?
Could be.
Might be a little sparky spark. And you notice there's you see where the ant stuff. Yeah. Nice call.
A lot of people might say, well, whoa, wait a minute, he's not completely clamped on there. He doesn't have to be completely clamped on there to pick up the voltage, but we're going to run our test here in a minute, and if we're off just a little bit from maybe 0.2, what we normally look for, or some people look for, depending on your utility company, of what you say pass or fail, you got to think that's going to have a little bit of effect. It'll be a fine line, but it could be the difference between 99.2 and 99.8, you know, so it could be a difference there. But that's our only access points we've really got. Quick mention, the bag down there, upon further inspection, is actually ant poison, the bag down there. So it's not a snack bag, so we feel better about that. And now, in some cases on these, you have to figure 8 your flex, okay? But in this case, when we're right there on top of the CT like we are, and we've got both of them through the one, you've got A phase is going through the correct way, and B phase is going back in the opposite direction. So it will subtract those and give you the correct, it'll give you your correct current going through there by looping around both of them, okay? So he has his arrow in the direction of A phase, the current flowing in A phase, right? But then it's going to be backwards on the B, so the two of them subtract one another. So we also, it is a dual tapped CT there, and when we run the test here in a second, you'll see it's going to be a 400 amp. So it's either 200 or 400 to 5. It is going to be a 400 to 5 once we run the test here, okay? So we're picking up our voltages here, A and B phase here. You can see where we've got our neutral connected over here coming off of our spades here, right? But then we just had to come and find the best point of contact that we could make, the safest and best point, and we got there and there on A and B phases for our voltage. We connected our neutral there. We're picking up our secondary current here. We've got, right, our one actual current right there. Okay, we've got our two voltages. So when he selects his service in there, you're going to select 2 voltages, 1 current, right?
Correct.
And that's the one that he chose. He chose a 3.
So remember how we work here between our CTs and the meter. So we've got 2 conductors running through the CT, right? We've got A and B phases in different directions. But remember, I'm coming off the secondary terminals off of that CT, and I come into the meter here. That's why I just have the 1 connector right here, because it's done the summation and everything through there, but in the end result of it, I still have just 1 coming into here. So that's why the meter, and I'm going to point this out here in a minute when we show the vectors, it does that meter math we talk about, where it's going to do the summation, the meter will do the summation. But coming off, I've got 2 primary conductors running through that CT. I've just got that 1 feed coming into here, so it sees it as 1 current and 2 voltages. Okay, cool.
Yes, we've got 1 current, 2 voltages, and that's how you set it up in the kit. And by going around both of those conductors at the same time, one going in one direction, one going in the other direction, they're going to go ahead and they'll perform a summation on the 2 of them, and the 1 will subtract. The B phase is going in the wrong direction, so it will subtract off of the A phase going in the correct direction. So we'll come over here to the machine now.
Just like always, start by looking at the vectors. Just
Right.
make sure everything's the right direction, everything looks good.
You're looking at your primary real quick just to see what it looks like.
So that's my secondary right there. We know we got about 1 amp of secondary, so
Sure.
we're good there. The voltage looks good. Should have,
Okay, so let's talk about this for a second. So if you look here, we talk about that number, and we know that all of our revenue level CTs, all of them are 100 to 5, 200 to 5, 400 to 5, 600 to 5, 800 to 5. It's always 5 on that secondary side is what, if they're fully loaded, if on a 400 to 5 CT, if I have 400 amps on the primary, I'll have 5 amps on the secondary. So it's always 5 is what the ratio is to. Well, that's why the number we look for is, according to ANSI, and ANSI says you want, at least for it to be a legal ANSI test, you want 10% loading on the primary of that CT. That means on a 400 to 5 CT, I need at least 40 amps on there. Well, if I do a ratio, you can look at it as a scale. Whatever I do on one side of the scale, I do to the other side. So if I take 10% over on the primary side, and I take 10% of 400 and get 40, I take 10% of the 5 on the other side and I get 0.5. Well, since it's 5 always on that secondary side, no matter what I do for a legal ANSI test, I need to have at least 0.5 secondary amps. And that's why he looked right here and he said, hey, I've got 0.995 and I've got 0.995 here. So looking at this, that's my system total, but I only have the 1 current here anyway. So looking at that current, I say, hey, now I've got 0.995. I've almost got 1 secondary amp. So I'm twice what I need. So I can think, I'm feeling good about getting the test. If you get below, then that's when you start saying, uh-oh. If I get below the 0.5, number one, I know it's technically not a legal test, but that's when I know the lower it gets, the more of an issue I'm going to have testing those CTs. Because no one's machines out there like it when there's low current on the CTs, because the CTs perform poorly when you underload them. Remember the old bathtub curve. So when I get below 10% of that, my accuracy starts going bad quickly, okay? So I want to have at least 10% on there. Don't always have that. I've tested them and where they've tested when it's been extremely low. Last year I set the record with the lowest one I've ever tested. It was crazy low. But to be a legal test, and again, if you get into something, unfortunately you don't want this to happen, but you get into it with a customer, they can say that isn't even a legal test. There wasn't enough on there. But it happens to us because the place that's now just a big warehouse full of lights at one time was full of machinery. So there's 800 to 5 CTs on it. But the CTs don't get changed. And now we're looking at 800 to 5 CTs when it's just some lights. So we know it's going to be unloaded all the time. So in cases like that, you start seeing those numbers start getting below the 0.5 on that secondary side, and it's going to be tougher to test them. So that's why initially he looked at that and he saw, okay, I've got 0.995, I should be fine. Another thing to point out here, you'll see right here, secondary voltage AB. We've said this before, when you're using one of the phases as a reference for the other, that's when you see more than one letter on here, okay? Because you think of a Y, a nice clean Y with a neutral on there and everything's to neutral. So you got voltage A, but really you could say voltage A to neutral and voltage B to neutral and voltage C to neutral. But in this case, when I see VAB, then that means I'm using B as a reference right here, okay? So because I've got my current is A, but my voltage is AB. So when you see more than one letter on anything on a vector, that means one of the phases is being used as a reference, okay? Thanks.
240, we got 248.
That's right. So we'll
Toggle over to primary.
And we didn't see something crazy, right? We didn't see a big change in the vectors to make us go, whoa, whoa, whoa.
So when you hit that and you toggle between secondary and primary, what am I looking for? I'm looking for where, if I had an issue, let's say I saw a polarity reversal and my current was way over here. If my current moved, then I got a current problem. If my voltage moved, but here's where we got to get a little technical about it. Your voltage on A phase is always going to be right here, no matter what. And that's sometimes that can be a zinger when the voltage is actually swapped. Because the voltage on vectors on any machine is always going to show it right there at 0 degrees, no matter what. It's a weird one, but even if it should show it over here, if you had, let's say you had a PT involved and your PT on A phase, someone swapped the wires. Okay, polarity or voltage on the voltage should really show it over here. It won't. It'll show it over here. And that can really cause you a headache, okay? Just a little sidebar, which I want to do. But anyway, so this one being the open head is always my voltage, solid arrowhead, and darker is always my current. But if my current swung over here and I had polarity reversal on my current, that would mean I got a CT issue. I've either got the primary or the secondary has polarity reversal on it. A secondary polarity reversal is typically going to be these two wires are swapped right here on my CT, okay? It could be those two wires swapped there, or it could be swapped down in the can right here. If for some reason they didn't come off of here, when they came off of the dot side of this CT and they came up into this test switch, instead of coming into the shunt blade, they could come into the return blade. And then if you put your duckbill in the way you normally put it in there, it's going to show with the white side up, which is what you think it should always be. If you put it in that way, you're going to show polarity reversal on the secondary side. So anything from these secondary terminals on through that whole test switch meter and back to the return right here, that's secondary for us. These conductors running through here and that CT itself is primary. So determine between a primary and a secondary problem, that's why you do the toggle right there. For us, it's F4. This F4 button right here. When you hit it, it toggles between primary current and secondary current. And when I toggle to the primary, if I had polarity reversal over here, which initially it's going to show it on the secondary side, if I toggled and hit that primary and it stayed right there, that would mean I have polarity reversal on the primary, because the primary is, when it has polarity reversal, the secondary always follows it, okay? So if you initially turned on the machine, looked at your vectors, and it shows secondary and it shows polarity reversal, and you toggle over to the primary, it may show polarity reversal also, because that secondary is going to follow that primary. But if you saw that secondary current polarity reversal, but when you toggled over you didn't, now it's going to show 180 degrees out. When you actually run the test on the CT, it's going to give you polarity reversal. It's going to give you 180 degrees out. It's going to give you a fail on the test. But here's the big zinger. If it is on the primary, if you had a CTM backwards or you run your conductors the wrong way, those two will follow one another. You won't see the 180 degrees out. It'll say that it's a good test and it'll pass. And everybody in the field, when I do that, and I say, now what's going to happen? Is it going to pass or fail? Your inclination is to say it's going to fail. No, it won't, because they followed one another. And when they follow one another, they're not out of phase like that. But if the secondary alone goes, now you got the 180 degrees out. You see what I'm saying? So then you're going to get that whole polarity reversal, a fail, and you'll look down there and follow the red and see 179.9 degrees out. But if it's a primary problem, either that CT being in backwards or those conductors run the wrong way, they're going to stay in phase with one another, and you won't get a fail. That joker will pass. And I feel bad now in the first years that I worked here that I had people telling me, yeah, sometimes the angles will look crazy and that, but it tests fine. No. Then that means that you did get, that it could be that you had a CT in backwards or they ran the conductors the wrong way, because the test will come out fine, but when you look at those vectors, it's going to look like polarity reversal. But sometimes we're out there just looking for a pass. And if we get a pass, and everything's cool, then we think everything's fine. Not necessarily. You can get a pass, and have one of your CTs in backwards, losing 2/3 of your revenue, and walk away from that site thinking everything's cool. So it's so important to look at those vectors, but not only look at them just on the secondary side, but look at them on the primary side as well.
Why is it so different between primary and secondary? And it's not. So we feel good about that. So we can go back to our secondary again. Cool.
So we're looking good.
It's looking good so far. So we'll run the integrated site test. And remember, the integrated site test, first it's going to do a customer load test on the meter, and then it's going to do a ratio burn test on the CTs. So he's going to enter in, did you enter 30 seconds or 3? Or just
I left it since we've got a full amp on it. We'll go ahead and get it.
Oh, wow. If you got a full amp on a secondary.
Okay. And see here, you're showing right here on the screen, you can see up here where it's showing, generally when we're going to test a 2 voltage, 1 current like this, what we're doing is, we've got 2 phases A and B involved, but we're doing the meter math and the summation that we talked about at the site. So you can see here it's showing a figure 8 between A and B phases right here. And what that does is when you figure 8 that flex, remember it's got an arrow, right, that tells you that anything that measures current has to be directional because current's directional, okay? So in this case, when you figure 8 it, that's going to mean the arrow is going to go one way for A and the other way for B. So what happens then is it picks them both up correctly, right? And then it'll do the meter math, and the machine will do the math just like the meter, and it'll come up with it. Or in this case, we just looped it around both of them, and we let the machine do it. So the machine's doing the math because it's got B phase is going one way and A phase is going the other way. So if the 2 are flowing in different directions, one is going to subtract from the other one, okay? They have to be both going in the same direction for them to add. So we say summation, but sometimes actually it comes out to be, it's really subtraction. But it's just the summation of the phases is the way we call it. So it's going to do a summation of the phases, so you can either figure 8 it here, or you can go ahead and just wrap it around both of them. And in this case, it's always per the installation, because remember, as you figure 8 it, it shortens it down. So they got to be nice and close together. And in this one, we had one phase that was down there really, really tight and low when we see it again. And so it would have been tough to do. So instead, we just went around it one time. You probably on this one could have done a double wrap. The thing is, and Jonathan, I believe, even makes a comment about it. Look, it's all about getting home safe to your families in one piece. So the more you get in there, and this was a pretty tight one. You got the primary so close there. So he got the one wrap on there and called it a day. And I have absolutely no problem with that. Okay, so that's what we did in this case. But if you wanted to, you can also double wrap in a situation like this.
It should run
240 volt with a full amp secondary. It should go pretty quick.
Absolutely. It should run pretty quick there. So we should be fine. So our color diagram showing us where we should make our connections. Looks like we've got it connected correctly here.
We come down a little bit on load, but about a half amp now. Chances are it'll go back up somewhere during the test, but it should still move.
So as always, you're waiting for the large green dot to light up and give you a tone. And then over here to tell you can start test. You can't start the test until you get a good pulse there. So we got a good pulse. So we're going to start the registration, and what we're always looking for here is we're counting the pulses right here off of the pickup. Then we're comparing that to what we measure. So if we count one pulse, we know that from what he's put in there is 0.6. So as soon as he sees 0.6 amps in there, then he knows that it's going to give us a pulse. So it's going to start counting off of that, and we're going to compare volts times amps times power factor and come up with the watts. And then we'll say, well, off of what we measured, it should be this many pulses or revs, but what did we actually count? And when it compares the two, that's our customer load test, right? Whereas a phantom load test would be where we're going to supply the current. We're actually taking it right off the CTs here, and we're using that.
So off of the covers, remember we were talking about, because we were having to make that connection with those alligator clips, we didn't get it as accurate as we would like. And with anybody's equipment and with ours, what you're doing is you're going to set up what's pass or fail on there, okay? And clearly the 99.4 was outside of the range that we said was a pass. For instance, if you say you set it up for 0.2 as the pass or fail, that means that's the range above and below 100%. So if you make it 0.2, sorry about that. If you make it 0.2, then it's going to be 99.8 to 100.2 is pass. So in this case, it didn't meet that. So as a matter of fact, what happens in that case is it tells you down here possible error because it fell outside of that range.
So if you look at it, 99.4, like we mentioned before, considering the connections and how we've gotten in here, that's actually pretty good. So because you would expect to see a little bit of a loss in there because of the way we've had to make our connections. But he had to work some magic to make these connections work on this one. Had to, that's pretty tight fit on getting his clamp on in there and then finding a place to pick up his voltages. So if you look at all of that, the 99.4 is not really too bad. So now we'll go ahead and test the CT, where we've got it looped around both. And you can show here, it shows on the diagram a figure 8, but in the way that he's got it that close, you got another choice if you can go around both of them if you're that close. If you think about it, if he had a separation between his two conductors and couldn't perform the figure 8, because remember when you figure 8 it, it also shortens it up, right, when you figure 8 it. So in this case, he was able to get around both because he was able to get so tight right there at the CT. So he got around both conductors. So you have two options when you're using your flex probe to try and test these. Figure 8 it if you can't, if they're a little bit farther apart. But if you can get around both of them like that, then you go ahead and do it this way. So that's what we did. So like I said a minute ago, it's showing that the nameplate's 400 on there, right? So the nameplate's 400, so clearly it's a 200 to 5 or 400 to 5 tapped CT, so you can tell it's tapped 400. And so, so it is a 400 amp like we suspected. You can see that we're getting a pass on it, so we don't have problems with our phase angle error or with our ratio, so both of those come within spec, so it gives us a pass, the green pass on there. If we had a problem either on ratio or on the phase angle error, it would have given us a fail on it, a red fail. So when we get both the tests good, we get a test good on the meter and on the CTs. In this case, you know, you're going to have to do some finagling on these if you have to figure 8 them. But if not, you can go around both of them. So you got the bigger hoop to get around both of them if you're up close like that. If not, you may have to figure 8. But in this case, we were able to get around both of them like that because they were so close to the CT and my conductors still so close together. So we went ahead and just did it that way. Okay. Would you ever double wrap in that case?
You could.
Right. So you could.
Just this particular setup where you're kind of tight on that B phase right there and you've got the primaries near it, I tend to try to play around in them as little as possible.
That's right. Yeah, because remember now, our primaries are right there on top of us in this case, okay? They're very, very tight, and we're right on top of those primaries. So I like what he said, and that's another reason you hear us mention in other situations where in cases where we have 3 flexes, we're using those. We like to, instead of using one and moving around and staying up in those transformers, it's always just a general safety practice to get in there and then stand back out of that thing and get all your testing done rather than being up inside that transformer. So he made a loop right there around both of those. Worked out really well for us. But as we said, if he wanted to, he could have stayed there a little bit longer and tried to play with it more and try and get a double wrap on it. In this case, everything worked out okay for us. We got a good test on the CT, so everything worked out in this case.
Well, appreciate that. Hope you guys found some useful information out of that. On the 26th, it'll be the week after this one. We're going to have that round table. Please send in some questions to JP. Your email address is Jarrett, JARRETT .Peters, PETERS at, are you at Power? No, you're at TEC, right?
TEC, or you can send it to Powermetrix. It'll get to me.
Oh, cool.
Yeah.
At Powermetrix.com, and JP will get it.
Yep, and I will also put a text field in the registration form. Whenever I send out that email that says register now, and you click that button, it just asks for some basic information. I'll add one more field where you could submit your question.
Oh, cool.
So you can either submit your question when you register, or you can just send it directly to me, jarrett.peters@powermetrix.com, and I'll put that in the chat.
Beautiful. And that way we can answer some of your questions and address them while we're having the round table. Looking forward to Martin and Kent coming in, and looking forward to Mid-South Meter School. As a matter of fact, I better answer that phone call now. It was the president of Mid-South Meter School this year, Todd Street. Don't want to get in any trouble. I try and stay out of as much as possible, but unfortunately it doesn't work out that well for me. But I'm going to call him. And again, just really appreciate everybody. Appreciate all the comments coming up to us at the school. JP did a ton of work on this, not just there in the field, but behind the scenes. Y'all don't see what all he's got to cut and paste and do, and even just avoiding with the camera work, trying to keep trying to keep me out of as much as possible, but sometimes he has to. But anyway, so a lot of work goes into this, and so we really appreciate it, all the comments and the thanks and everything you guys give us out there. So thanks, God bless y'all. Be careful, all right? And I'll see y'all at Mid-South.